Welcome to our tutorial of ProfLearn YouTube channel. In this particular video, we're going to have a discussion of the topic nuclear physics, and you get to see which are the questions that are going to be asked in this coming exam. So we are going to discuss how to answer questions with nuclear physics. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials and more tutorials on including predicted papers, you'll be notified. The topic is radioactivity, and in this particular topics you can be asked questions to do with types of radiation that are emitted, which are alpha, beta and gamma radiations, and we need to understand different penetration ability of each of the alpha, beta and of each of these particles that we are having here. So let's just dive in and get to see what are the main questions that can be asked. A teacher investigates the type of radiations emitted by three radioactive substances. So in the event you are asked to name the equipment the teacher could use in order to measure the count rate in this investigation, this could be the Geiger-Müller tube, or a GM tube, or a cloud chamber. Those are something that you need also to remember is sources of background radiations, and in this case we shall talk about sources like cosmic rays from space, nuclear and medical activities can act as source. You need also to understand the definition of half-life, and we shall say this is the time taken. So whenever you start defining half-life, you must start by saying time taken for the activity of a radioactive substance to decrease by a half. So you need to also remember that you can be given a question from a graph and you are supposed to determine half-life. So if this is 1,000, you need to divide it by 2, you get what? 500. Then you check out the 500, you read the point, a straight line to check where it meets the graph, and you read the value down here, and that is going to be your half-life. Now we are told that estimate how many days it will take the count rate source to be below 100, but the initial count rate was 780 and the half-life was 6 days. So you need to start with 780 divided by 2, that will take one half-life. You get this value, divide by 2, 195, and divide by 2, you get 97.5. So this now is below 100. You can see we have 1 half-life, 2 half-life, 3 half-life, and each half-life is 16 days. And now therefore that means 6 times 3, that gives us 18 days for it to be below 100. If you are new to ProfLearn YouTube channel, consider subscribing so that when I'm going to upload new videos on more of a concept that will be tested, you will be notified. Now we are told that americium-241 is a radioactive isotope. What's an isotope? Isotopes are atoms of the same element which have the same mass, same proton number, same atomic number, but different mass number. And the difference is due to the number of protons available, because protons plus neutrons gives you the mass number, but the proton number remains the same. The number in the lower part here is the proton number, and the number at the top is the mass number. How many protons are there? Protons are equal to the number of electrons, so the number of protons are 95. How many neutrons are there? Neutrons, we know protons plus neutrons will give you the mass number, so we say 95 plus neutrons should give us 241. So if you subtract, our n is going to be 146 as the answer in this particular part. So these are the kind of questions you'll be asked in your paper, physics paper, and you have to know how to answer them. How many electrons are there in a neutron of americium atom? That would be 95, because the number of protons is equal to the number of electrons. But we know that in the inside the nucleus we have protons and neutrons, but around the nucleus we have electrons which are orbiting around, held by electrostatic forces. So that is also another question that you can be asked. You'll be asked also question to balance a nuclear reaction. And for this case, if we are talking about alpha particle, is actually represented by the helium nucleus, and beta particle is represented by an electron, because beta particles are fast moving electrons. So you need to understand that electron has a mass number of 0 but atomic number of -1. So if you are balancing, if this was 95, we don't know this. This one is 2 for helium, and for alpha actually is 2, and the mass number is 4. So the top we have 4, which will balance. You see 237 plus 4 will give us 241. And if we have 2 here, this has to be 93, so that it will add up to 95. When gamma is emitted, remember gamma is an electromagnetic wave, so it does not affect the number of protons and neutrons when it's emitted, because it's just emitted to release some excess and extra energy in that given point. So we are supposed to say the number of protons and neutrons remain the same when during gamma emission, but during alpha emission, the number of protons decreases by 2, and the mass number decreases by 4. For beta emission, the mass number remains the same, but the proton number increases by 1. Increases by 1. You have to take note of that. Take note of that. I believe you are learning and you are getting something from this discussion, and we are told that smoke detectors actually use alpha particles, because alpha particles are good ionizing and are good at ionization. They can be also, alpha particles can be absorbed by smoke particles. Explain how rising smoke causes alarm to sound. And we are told that the alarm will sound when the count rate go below 80. So meaning that if there is smoke rising from here, smoke will absorb and block some of the alpha particles, and then the count rate registered is going to be what? Is going to be less. So in that way, this reduces the count rate, and the count rate will go below what? Will go below 80 as indicated there. Then it means that now the alarm has to sound and to produce sound in that case. Now, americium-241 has a half-life of 340 years. Describe what's meant by half-life. We said half-life is the time taken for the activity of a radioactive substance to decrease by half, or the time taken for the mass of a radioactive substance to decay by a half the original. Americium-242 has half-life of 16 hours and emits beta. Explain why americium-242 is not suitable to use for smoke detector. Now you can see canaricium. My student was asked if this is called americium. Could it be there is a radioactive substance called canaricium? If you are coming from Kenya, is there any called canaricium? If you are coming from Canada, can you confirm to us in the comment section below? Do you have in your country a radioactive called canaricium? If you are coming from Canada, if you are coming from South Africa, do we have sautaricium? Yeah, so you say, just comment in your country. You can say that in my country is Australia, we don't have australicium. So just leave a comment down below. So we are going to say beta particles do not ionize air effectively as alpha particle does. They have higher penetration power, and that's going to affect the life of the people around, so they can penetrate into the body. And also we were told that they have a short half-life. Now we can say also from there, with this short half-life, Americium will decay so quickly, so that will require frequent replacement. And now this one will be a disadvantage, because the smoke detectors requires long-lasting radioactive substance. Otherwise, you'll be having a smoke detector that is useless. That's useless. Now, we are talking about another concept here, and we are told that this question is about food preservation, and we need to understand that radioactive substance can be used for food preservation. And in this case, we're going to use gamma radiation, because gamma radiation have the ability to penetrate materials, and also they have high enormous amount of energy, which can be able to kill living cells and also microorganisms. Now, the question that is very interesting here is that explain why gamma radiation is used instead of alpha radiation. Gamma radiation is used because gamma have high penetration ability and can penetrate wood, while alpha cannot. Yeah, so explain why gamma radiation is used instead of alpha radiation to kill bacteria. I think we need to also focus on a most important aspect in this part. Apart from having a high amount of ability or penetration ability, we can say gamma has high energy that can kill microorganisms. So they have high amount of energy, and which can kill microorganisms. At the same time, they can be able to penetrate through the wood, while alpha cannot be able to penetrate in that case. Explain why fruit irradiated, because this is the mark that is usually indicate these fruits have been irradiated, so that you can make a decision to buy or not. The reason as to why this is indicated when you go to the supermarkets to buy fruits, if they are irradiated, you will see this mark. The reason as to why this mark is placed there is because of the rising discussion whether gamma irradiated those fruits which are preserved by gamma radiation, they are safe because gamma is known to cause cancer. Yeah, so is it safe to eat these fruits which have been subjected to gamma radiations? So that's the discussion that has been all of us. So that's why, for safety measures and for precautions, a rule was passed that you have to indicate that they are irradiated, so that the person can decide whether to buy or not. So something that we need to mention, they are safe to eat because gamma radiation kill germs. So already we don't have germs and bacteria in this, so they are safe to eat. The other reason we're going to say is that irradiation does not make the fruits contaminated, or radioactive. So it's safe to do what? To eat. So it's upon you to decide, but this is the logic behind. We can be able to eat them because they don't become radioactive, they are not contaminated. What has just been done is that this food has been subjected, the radiations have been directed. This is only the radiations that have been directed which kill the germs that could be inside here. Irradiation does not make food contaminated. But what is contamination? Contamination is when a radioactive substance, now this is a radioactive substance, has been fallen inside food, so this food become radioactive. This food gives out radiation. Now this food is not safe for consumption because this food is contaminated. So we need to move further and look at other questions that were asked. But what I need to say, this question mostly they are just repeated, just a repetition. You'll be seeing the same questions in your coming exams. The name of instrument that the teacher could use to detect radiations is actually the GM tube or Geiger-Müller tube, and I've just illustrated the Geiger-Müller tube here. Of course, we use it can be able to detect the presence of a radioactive substance, and then the count rate is produced, is registered on the screen, and also some sound are produced. The units for radioactivity is actually becquerel, and sources could be rocks and buildings, cosmic rays from space, and also radioactive, nuclear, and also medical activities. Describe the procedure the teacher should follow to measure the background radiation and correct the count measurement. So first, the teacher should measure the radiations when there is no radioactive substance. Repeat and then find average so that we can be able to know the background radiation. Then measure the count when they measure the reading when there is a radioactive substance, and then record. For instance, if you record 9650 when there is a radioactive substance, and if when there was no radioactive substance was 500, then now the corrected count becomes 9650 minus 500, and that becomes what? 91. Okay, let's just use our calculator there. We have 9650 minus 500, that's translated to 9150 becquerel, BQ. I know they will ask you the units for measuring the activity of a radioactive substance. Tell them it's becquerel, BQ. So corrected count formula is count reading minus the background count. So those are the concepts that you need to understand. Further, we are going to talk more of this topic. So we shall talk about the nuclear reactors, we shall talk about graphs, and then how you are supposed to approach more questions. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. See you in the next video.